Good day, everyone. Our topic for today is implementing if-else in MASM assembly. Our learning objectives: by the end of this lesson, the learner should be able to describe the basic structure of a MASM assembly program, including memory models and segments, declare and initialize data variables and string constant in the dot data segment, understand and use comparisons instructions CMP to set flags for conditional logic, implement conditional branching logic or if else using labels and conditional jumps such as JA, JB, and JE. Use those interrupts to display output by passing string addresses to system calls. Differentiate between signed and unsigned comparisons and choose appropriate jump instructions such as JA, JG, and so on. Successfully assemble, link, and run a simple MASM program interpreting its output based on the conditional logic. Here are our key topics. Number one, MASM program structure. Under that, memory models or dot model small, segment dot stack dot data dot code, program entry and exit, the main and main. Number two, data declaration, declaring and initializing variables, DB, message string in the dollar sign terminator for DOS printing. Number three, registers and data movement, general purpose registers, AL, AX, DS, and DX. MOV instruction or MOV instruction for loading slash storing data. LEA or LEA for loading addresses of variables. Number four, comparison and conditional branching, the CMP instruction for value comparison. Unsigned conditional jumps, JA, JB, and JE. Label-based control flow, the if-else logic. Number five, string output with those interrupts, interrupt 21H, function 09H for printing strings, using DX to pass strings addresses to DOS. Number six, program termination, DOS function 4CH to exit the program, and int21H usage. So this is our introduction. So this lesson introduces learners to implement conditional logic using assembly language, specifically in MASM or Microsoft Macro Assembler. Using a practical if-else structure, learners will explore how low-level instructions like CMP, JA, and jumps simulate high-level decision-making constructs. The lesson focuses on the first one, understanding the structure of MASM program, defining and comparing variables, controlling program flow with conditional jumps, using those interrupts to output text, safely terminating a program. Again, by the end of the lesson, student will have a written, understood, and modified simple MSM program to compare two numbers and prints the result on a conditional check. This foundational skill enabled to build more advanced such as loops, nested conditions, and procedures in assembly language. This is our goal in our topic for today. We want to compare two numbers depending on the result. So the output will be, or the first, it will print num1 is greater than or is greater if num1 is greater than number 2, or else print num2 is greater or equal. So we are comparing two numbers depending on their value using assembly language. So this mimics the high level code. In other programming language, this is our logic. For example, in C or other programming language that you are using or familiar with, for example, here, if num1 or this is the logic, num1 is greater than num2, print f, num1 is greater if it is true, and if it is false, or else print f, num2 is greater or equal. It means that num2 is greater than num1. So, and this is the one example of mimicking the high level code or other programming language. But in our goal here, we're going to create a simple assembly language code, MASM code that mimics this if else statement. So the concept used here I'm going to read the concept. CMP means compares, or the keyword CMP compares two two values by subtracting and setting a flag. JA, jumps above, means jump above or unsigned, used after CMP or comparison. LEA, load effective address, um, used to get string addresses. And 21H, those interrupts for the system exit. Okay, so I have here the actual code. So let me check first. Okay, so here. So I already created a code here. I'm just going to show you. So this is the actual code of our we're going to discuss today. So I already have here some labels. By the way, we already done discussing how we're going to put comments in assembly language. So I have here model small, then stack 100 H that defines this setup. So we already done discussing in the previous topic, the previous meetings, no? And then dot data, this is the begin the data segment. Num1, db5, this will be defined the byte value. So we're comparing the value of num1, or the variable num1 will be 5, and num2 defined byte, db means defined byte, value will be num, or num2 will be 10. And the message will be that we're going to print is num1 is greater. So message to show if num1 is greater than num2. Message number 2, or db, num2 is greater than or equals, or this will be the else message. So in the dot code, this will be the code segment here. And then this the main, like I said, we are discussing a while ago in our introduction, and the objectives, no? And then here in the main, this will be in this part, like we already discussed last time. This will be the beginning of our code. Consider if you check here, this will be all of the declaration of the variables, and this will be the actual code or the logic. So move AX at data, so load address of data segment into AX. Move DS AX, initialize DS register with data segment address. Move AL num1, load num1 to AL register. CMP AL num2, compare AL the num1, which is 5 by the way, no, with num2. JA greater, jump the label if AL, or the num1, is greater than num2, which it is, we use JA because it is an unsigned comparison. And then we have here the else block if num1 is less than or equal to num2. You can remember, you can see here the comment here. This is just only a aesthetic, so you can have separation. Okay, so in the else part, lay a dx message to load address in message to into dx register. JMP means jump, print message, skip the next block and print, and jump to print. And we have here another if block. Okay, this is just only again a comment. Greater. So lay dx message 1, load address in of message 1 into dx. Then print routine. So print message, mov ax, mov ah09. This would be the DOS function, so to print string at ds colon dx, ending with the dollar sign, which is the string, no? And then in 21H to interrupt the DOS, to call DOS interrupts, interrupt move AH for CH DOS function to exit the program. And then 21 in 21H control, return to control to DOS, and then the mark of the end of the program. So I have here the simulation. So if you can still remember, we are using DOSBox as an emulator for our what, assembly code. So let me open first my my DOSBox. So just going to open the DOSBox. Let me show you the actual code. So it takes a lot of time to load, you know. So yeah. Don't worry. The copy of this sample code will be sent in our Google Classroom, by the way, or on our link in if here. I'm just going to share with you. I'm going to provide the source code here. So the first thing we need to do, so this is just a review of what we have done in our face-to-face meeting or face-to-face sessions or previous sessions, no? So in our laboratory, so we need to first to mount our folder, and then switch to our disk drive and click edit. So I already code the logic there that I already discussed a while ago. I'm just going to open. You can post the video and then copy those codes. So I'm just going to find the if else MCM, no. Okay, so this is our code. If so, that's the a while ago I already showed you this code in a note in Notepad, but here in our actual editor in DOSBox, no. Then I'm just going to save the file and then exit. I just want you to show you this the code with actual running, no. And then yan. Okay, so the first thing we need to do is to compile MASM, then the file name. If you can still remember, the file name I used if else, then the file extension MASM, and then here we put this object obj is if else dot obj. Then just enter this, and then if you check if there are some errors here, so we don't have errors, so we need to link here our what do you call this, our compiled obj of the if else obj. So if else dot obj, then enter, just on enter, and then we need to run the file, the exe file or the output file. If else dot exe, and then num2 is greater than or equal, or num2 is greater than. Why is it that it is greater than? If you can still remember our code here, we declared num2 is 10. Okay? So automatically 10 is greater than 5, so the output will be num2 is greater than or equal. So yeah. Okay? So that's the actual code. Next. So let's go on to discuss part by part. Here are our key instruction in detail. So CMPAL num2, this subtracts the num2 for all AL but does not store the result. So we're just comparing or subtracting, no? It only sets the flags, zero flag, carry flag, sign flag, and so on. No? So we use these flags in conditional jumps. So may jumping tayo. Okay, so JA greater means jump above unsigned. Jump if CF is equal to 0, Z CF, and then zeta F equal to example greater. Since num1 and num2 are unsigned bytes, we use JA because DB, we use defined byte. Since if you're working with signed numbers, you use JG, jump greater. JA means unsigned, and if it is signed numbers, we use JG. And then Leia DX, message 1, and MOV H and 29, 09H slash 21 int 21H. This is how we print in DOS or this operating system, no? Okay, so Lea DX message 1 load address to string DX, move AH09 DOS print function, and the 21H call the DOS service to display the string. So note, if you can check, if you can revisit those code, we have dollar sign character to print, no, the this string must end a character dollar sign character for this method. So mov AH 21 rather 4CH slash 21H. This exit the program and returns to control to the operating system or the MS-DOS. Okay, so AH equals 4CH equal terminate the program, and then in 21H will DOS interrupts. So the output of the example that I already shown with you is, since number 1 or num1 is 5 and num2 is 10, the program compares. So CMP5 10 not greater falls to the else part. So the logic, if we simulate, if 5 is 5 greater than 10, so automatically the answer will be false, and then skip. those logic will fall to the else part. So it prints number 2 or num2 is greater than or equal. So tips, if you're working with, like I said, with signed integers, we use JG, J1 or and JGE or and so on or etc. Always match data type. DB means byte with AL, DW is word and with AX. Okay? Use labels to simulate control flow if, else, and if. So we have here our guide question. You can pause for a while if you, after I read this guide question so that you can have you can think the answer. So here, let's start. Number one, what does dot small mean? I'm going to give you time. You can pause the video. Okay. So the answer will be it tells MASM to use a small memory model, one code segment and one data segment under 64 kilobyte. Number two, another guide question. Why do we use dot stack 100H? Again, pause for a while. Answer this question, this guide question. Okay, done. So the answer, it allocates 256 bytes for the stack. Means 100H is 100H in hexadecimal. Number 3. What does DB do? It doesn't mean database, huh? In assembly language, what DB means? Okay, the answer, it defines a byte of a data. For example, num1 DB stores 5 or the stores DB5 stores the number 5 in memory. Number 4. Why must string ends with dollar sign in this program? Okay, the answer, because those functions 09 it uses dollar sign to know where the string ends. Like we have discussed a while ago. Okay. Number 5, what is the purpose of mov ax at data and mov ds and ax? Okay. The answer, it initialized the data segment register so we can access variables in that data section. So if you can still remember, right, in that data, so those are declaration of variables. Okay, so we need to access those declared variables data in the dot data section. Number 6, what does cmpal num2 do? Okay, the answer is it compares AL with num2 by subtracting and set flags. Example, zero flag, carry flag, and so on, based on the result. Okay, let's proceed. Number 4, what does JA greater mean? I already discussed it a while ago, class. Okay, so the answer will jump to greater label if AL is above number 2. An example, num1 is greater than num2, which is unsigned. Which we use JA. What happens if the jump condition is false? So for example, if num1 and greater than num2, and then if you check the logic, it became false, what will happen? Okay? So the answer will be the program continues to the next instruction or in the next in the else block. The same logic with other programming languages that in branching statement in if else conditions. So what is LX, Leia DX MSD1 or message1 used for? Okay, the answer, it loads the address of message into DX so those can print in. Okay? So we need I think we have more guide questions here. Number 10, what does mov AH 09 and int21 do? So we already encountered it in our previous sessions, right? In our laboratory classes. So it prints the string pointed to DX to the screen using DOS interrupt 21H. Number 11, how does the program end? How we're going to end the program or terminate the program? Okay, so the answer with mov AH 24C followed by 21 in 21H which exit the program safely. You can revisit our previous code, or you can go back in our video here. You can check the last part, and then we already have their comments how to end, or the how to end the assembly program. Okay. And number 12, what's the difference between JA and JG? The answer is JA is used for unsigned numbers, and JG is used for signed numbers. And then what would happen if num1 equals num2? What do you think will happen? So if num1 equals num2, okay, the condition JA greater fails. So it prints num2 is greater or equal, or the it will be number two num2 is greater or equal. Okay? So what we have here? We have here some key takeaways. So again, MASM program structure. Assembly program in MASM follow a structure format. Dot model, dot stack, dot data, and dot code. So each segment has a specific role in organizing memory and logic. In data declaration, we use DB, means defined byte, to store single byte values and string. Strings for DOS output must be terminated with a dollar sign. Register usage, registers like AL, AX, DX, and DS are essential for moving and processing data. DS must be initialized to access data segment variables. In conditional logic with CMP and jump, CMP instruction sets processor flags based on the values, a value on based on value differences. Conditional jumps like JA, jump if above, if you used these flags to control program. MASM does not have a high level construct like if you simulate them using labels and jumps. Unsigned versus signed comparison. JA and JB are used for unsigned values, and JG and JL and so on for signed comparison. Output with DOS interrupts, use 21 in 21H with AH equals 09H to print a string in DOS. The address of the string must be passed through DX. Graceful um, program termination. Use use in 21H with AH equals 24C to exit properly, and return control the operating system. Assembly requires manual control. Unlike highly level languages, flow control, data types, and memory access must be managed manually. Understanding register and CPU flag is the key to mastering control structure in assembly. We have here our references: Introduction to MSM Language, Irvin K. 2015. So, yan, nakalagay po dyan. So, hope you learned something from our lesson for today. See you next time, and have a great day. Thank you, and goodbye.